Awesome. Well, thank you. Just a heads up, I finished writing this presentation like 30 minutes ago. I haven't rehearsed it. I've never given it before. What started out as a quick, I was going to give a demo on a new feature that Step Finance has. It turned into a explanation on why that feature kind of stirs up some usability issues. But I believe they're warranted, right? First of all, who am I? If you don't know me, I'm Dana from Step Finance. I lead the back-end team. I've been in crypto since 2013, working in Solana for 4 years now. I'm a big Mountain DAO guy. I've been at all the Mountain DAOs. Do we have any Mountain DAO people in here? All right. All right. And Island DAO also. I'm also a Bitcoin maxi. I'm even wearing a Bitcoin shirt today. So, yeah. Yes. I'm probably wrong about something in this presentation, and you'll likely disagree with something in this presentation, so take the opinions that you like. So if you're here, you're already building on Solana, the next-gen financial layer. It's unlocked a lot of speed, performance, and it has come with this great user experience that we can now give users in the crypto space. Previously with Ethereum or Bitcoin, the usability has been a little bit wonky, but the performance has really opened the door to these really good user experiences. But there's a core value that's often under pressure, and that's privacy. And from the earliest cypherpunk visions to the launch of Bitcoin, privacy has been this foundational principle of crypto. And somewhere along the way, especially as we build out these UIs and dashboards and tools, we've started sacrificing a little bit of privacy for convenience, right? We've gotten used to the Web2 world and how that thing's doing things. So from the earliest days of crypto, privacy has been not just important. Privacy wasn't something that we decided to kind of add on to crypto. Privacy is actually the foundation of all things crypto. And so let's look a brief history of crypto, how crypto got started and why it's important. So for those of you who have never heard of it, the cypherpunks were a group of people that were deeply embedded in the late 20th century. The community included thinkers like David Chaum, Timothy May, Nick Szabo, and they believed that cryptology could power individuals to protect them against the growing threats of government surveillance and other surveillance, right? Any sort of centralized power. And David Chaum actually created the first DigiCash back in the 80s, which was the precursor to all modern cryptocurrencies. Eric Hughes wrote in 1993, "Privacy is necessary for an open society in the electronic age, and we must defend our privacy if we expect to have any." The manifesto became a rallying cry for building tools that prioritize privacy by design. So these cypherpunks, these weren't just like a couple people. This is deeply embedded now in the history of our industry and a lot of other industries. Some notable people you may know: Julian Assange, Edward Snowden. These are people that proved this wasn't just some conspiracy theory. It's not like there's saying that there's malicious state actors that are going to do things is some conspiracy theory. They proved it was true. And we're all familiar with WikiLeaks and the Edward Snowden leaks and that sort of stuff. They proved that governments were out of control with power and surveillance. And then there's also another member of cypherpunks named Satoshi Nakamoto, which I'm sure everyone here is familiar with, the creator of Bitcoin. And the addresses on Bitcoin are pseudonymous. And they enable private financial interaction without centralized oversight. And that's really the foundation of all things crypto. It came out of this cypherpunks movement, along with a lot of other freedom of information and freedom of privacy type of things. Satoshi actually wrote that he regretted lacking the technology to make Bitcoin, like, amounts of transfers and stuff completely private. Of course, later we saw things like Zcash and Monero come out with that privacy that Satoshi was unable to do. So why does all this matter? Why does this privacy in finance matter? Because finance is power, and we see that. Money is power. In systems where surveillance and control dominate, that's just the case it is. And true financial freedom requires privacy, because without it, decentralization is only surface deep. And this ethos drives not only Bitcoin, but this should be driving all of these ecosystems of decentralized financial activity. This is what drove the entire industry forward, is the ability to not trust banks, to not trust governments. You'll notice what I'm wearing today. I have on a hat. Anyone recognize this company? We can't trust centralized things. I'm also wearing a shirt with Richard Nixon on it, the President of the United States that took us off the gold standard. These are things that governments do to keep themselves in power. So does privacy even matter in Web3? When we talk about privacy in Web3, it's easy to focus on the technical details, the encryption, the decentralization, the anonymization, but at the core, privacy is about personal protection. And in the context of finance, this is super important, right? Think about what a public blockchain has on it. It has your transaction history, your wallet balances, associations between your wallets. And without privacy tools in place, anyone, including governments, corporations, and malicious actors can observe and analyze and track our financial behavior. And that doesn't seem like a big deal until it is. Until your financial activity is flagged and taxed and targeted for reasons beyond your control. In traditional finance, there's controls around these things, but often those controls are owned by the same people we're trying to get the privacy from. In Web3, everything's default by public, though. So this is where the concept of personal protection comes in. Privacy isn't about hiding your criminal behavior. It's about protecting ordinary people from the extraordinary consequences of surveillance. We've seen examples around the world where governments use financial systems as tools of control, freezing assets, blocking payments, enforcing censorship through economic pressure, downright denying access to forms of money. We see my government in particular, the U.S. government, loves to deny access to forms of money to other nations as a means of punishment, right? And it doesn't just hurt the governments of those nations, it hurts the people. We saw this in the United States in the 1930s. The government demanded that all citizens turn over their gold, and the government said, it's all cool, we'll buy it from you for $20. You know, these $20 bills we'll give you for an ounce of gold. And not a year later, they came out and declared that the value of gold is actually $35, not $20. And that's because they had collected it all. And these are ways that they devalue currency. Of course, we're in the country of Turkey. I think the Turkish people know just as much as anyone else what happens when you devalue currency, the printing of money. Just some of you may not know, the Turkish lira right now, I don't know how many it is to $1, but just, 17, 18 years ago, it was 1 to 1. That's how quickly currencies can devalue, and that's how the government can extract value from us. And it goes beyond all this. There's no reason to know what wallets are mine and how they're related. Malicious actors are all around us. One of the largest, if not the largest, abuser of personal data is insiders. This goes way back to as soon as it was possible, people were doing this. Look at telephone operators in the early part of last century. They would eavesdrop on their neighbors, right? If you wanted to know the details of anything in town, you could talk to the telephone operator because she was listening to everyone. You see it today also with police getting access to cell phone data and doorbell cameras, not for police reasons, but to enact personal revenge, to check if their wife is cheating on them. You know, they look up their wife's personal records and stuff. I believe any well-meaning application teams that collect data will inevitably leak that data through negligence or a rogue employee. You could see this just recently with Jupiter. Jupiter leaked emails in transaction data. Was it their fault? It could be argued. They misunderstood how certain wallets treated transactions, and they accidentally were sending email addresses out onto the chain. So when we design dApps and platforms and protocols, we need to do this with the understanding that protecting users is not optional, it's foundational. So before we move into the nuts and bolts of privacy UX challenges, I wanted to take a moment and talk about the principles that shape everything we do. A privacy-first approach, it has to be built in from the very beginning. It's not an afterthought. It's not a layer we add later. If we design workflows or data models or authentication flows, assuming access to user data, it's already too late. Privacy has to be a default setting. You also have to protect users from themselves. Users don't know this stuff. We onboard a lot of people into crypto. They don't understand the ethos, the background, the why it matters that you don't link your email to your wallet address. As designers and developers, we have to make the secure choice the easy choice. We have to prevent accidental leaks, minimize data exposure, and design interfaces that guide the user to safer behavior. And we see some of this in the Web2 world. You see, set your password screens that make you use symbols and numbers and things like that. And that's great. That's the right direction. You also shouldn't be collecting personal data at all. There's no reason to have someone's personal data. Every piece of personal data you collect becomes a liability, not an asset. Now, your marketing teams may disagree with this, but the truth is it's a liability to your company to own your users' personal data. If you don't have your users' personal data, you can't leak your users' personal data. A good example of mistakes here, I already mentioned the Jupiter one, but we also, there was a leak from Ledger, the hardware wallet. They leaked the addresses and names of everyone that had a Ledger wallet. There were subsequently break-ins of people's houses and robberies. To this day, I still get scam phone calls because people know I hold crypto and they have it linked to my name and phone number and address. I'm sure you all experience the same there. So marketing and design really struggle with this because in the traditional world, we love collecting user data, analyzing user behavior, and being able to run sales pipelines and advertising that hit users' inbox that's custom to them. We love spying on our users and delivering targeted advertising, right? And I don't have all the answers on how to solve these things because I believe there's some sort of delicate balance of these conflicting purposes. But a lot of attention needs to be spent thinking through the real needs. At Step, we don't collect emails and associate them to your wallet address at all. We do have a newsletter you can sign up to that probably runs through a third party, but it's not related to any financial data or your name or anything else. And the example of privacy protection I want to walk through and kind of how it caused some friction in the user experience is user profile information. The product team desired users to have a seamless experience on multiple devices and needs to store sensitive information, being a list of wallets. This means Step, the website, needs to remember your related wallets on all your devices. That means if I create an account on my computer, I can access that account on my phone where I don't even have those wallets, which means someone needs to store that data, which means Step needs to store that data. So the founders of Step and myself are strong believers in this privacy. We don't want to store anybody's data. We don't want anyone to know what wallets links, not even each other, right? I don't want anyone on my development team to know what all my wallets are. And it's not because I'm a bad person. It's just because it's the privacy I've come to expect. And these are user data points that need to be kept secure. So traditionally, the way a computer system would store user data, you authenticate a user, username, password type of deal. You can prove the user knows the right password because you store a hash of the password in the back end. And maybe you're proud of yourself for storing the hash of that password, not the real password. But right alongside of that, you store data about that user. And maybe you encrypt it because you say, oh, we got to keep this private. I got to make sure nobody can read this. So we'll encrypt it using our key. Well, it's your key. Any of the developers of that application can still get into that data. Sure, you can use an HSM device, right, or something advanced like that, but you still got to send it back to the user's interface decrypted. So it's still in transit, uncrypted. Of course, there's the SSL layer, but there is that section of code that you can read user data. You can log user data. You could access user data if you want. Let me find where I am here, sorry. Yeah, so this is no different than the bank being able to confiscate your money. If your user data is stored in some database, someone can change that user data. Your bank can go in and stop you from getting to your account. The bank can change the balance on your account. And I have no doubt that there's developers at banks that can log in and change a number in a database and change the amount of money you have. Sure, they put legal controls around it, but they don't put physical mathematical controls around someone not being able to change your data. And that's what crypto brought us. And we apply that to the financials of it. And we need to start applying it a little bit better to the user privacy side of things, the data privacy. And so this is where in Web3, the user experience starts to become a little bit wonky. Right off the bat, from authenticating the user, as a user, you might think that connect button on a dApp is logging in to something. It's proving you own the wallet. It's not. All the connect button does on a dApp is shares your pub key with the dApp. Doesn't prove you own it. So the way we do that in Web3 is we have the user sign a message proving that they actually own that private key. So right off the bat, there's a step just to log in. We've got another strange way to do things. Now in the next step, instead of owning the key we use to sign to encrypt the data, we need the user to own that key to encrypt the data, not us, because we don't want to be able to decrypt it. So where can you get that key, right? Sounds pretty obvious. Crypto wallets, they are a key. But the problem is crypto wallets, keys are made for signing, for proving ownership, not for encrypting data. And sure, there's ways to turn an ED25519 key into an X25519 key, but wallets don't support it. And even if one of the wallets starting supporting it tomorrow, the others would have to support it also. And it's just not something that's on the roadmap for wallets. And even if they did support it, the requirements for the step team is to be able to log in on a wallet, on a device that doesn't even have that key. So we need another solution there. And here I wanted to get a little more technical and walk you through how we encrypt user profile data on Step. It's not theoretical, this is how we're actually doing it, and I'll show you that in the demo shortly. First of all, don't write your own encryption. If you've been to software dev conferences before about security, don't try to roll your own encryption, you'll get it wrong. Definitely do your research. So we start with a browser-based encryption using the AES GCM. It's a standard secure thing for symmetric encryption. It means it's secure in transit and at rest. We don't store the encryption key anywhere. Instead, it's derived using PBKDF2, which is a password derivation function. And we use SHA-512 as a hash algorithm, 100,000 iterations for this thing. It's basically an uncrackable key, but it's derived from a password from the user. Using these things allow us to secure your user profile data in our database, and we can't look at it. There's absolutely no way I can decrypt the data that you've put in there. Next, I have a demo. It is a live demo, so typical warnings on I have no clue what's going to happen here. Oh, lovely. So I've got a new wallet here. It's a pretty empty wallet. I'm going to connect to Step Finance, and I'm going to create a user profile here. So again, I spoke about this earlier. This connect button, this is not an authentication mechanism. This is a way my wallet shares my pub key with this website. That's all. In fact, the latest version of Phantom and probably Soulflare 2 allow you to create a watch-only address. You can add anyone's wallet to your wallet and go connect to websites. It works fine. So here I'm going to do the sign up to access collections. I need to create an account. And it tells you here, this is to synchronize your data across devices and platforms. So I'll sign in. Oh, not sign in. I will create account. Gives us some information about that. It does have a toggle for using your Ledger to sign. Ledger doesn't support signing messages, only transactions. In this case, I'll hit it. It's going to have me sign a message that simply proves to Step that it's me and it's right now that I'm signing this message. This is where the user interface gets weird. Why am I having to put in a password here? Like, it doesn't make any sense, right? But it's because we can't use that wallet. I'm going to use this generated password, and I'm going to put it on my clipboard so I can reuse it in a moment. This is another part of the user experiencing, really encouraging a strong password here. We require a minimum of 12, not just 8, not just 6. So I'll create account. And now the data that I put in here will be stored across all of the devices that I log in on this with. We can create collections of wallets. I'm not going to do that. We don't have that much time. Address book. If I make frequent payments to people, I can create an address book with a list of addresses that I frequently use. Even things like appearance, dark mode, not dark mode. I don't know why anyone would use light mode, Waza. So now I'm going to log out here. That wasn't log out. Log out's down here. So to sign back in now, you would expect I just connect my wallet. I'm signed in. I'm not signed in because that didn't do anything. Signing in, I also can't sign in by just signing a transaction now. Why not? Because all the data associated with my profile is encrypted using that password. So I have to give the website my password, even though I can prove that I own this wallet. And this is where the user interface or the user experience just becomes a little bit tough. But there's a reason. The reason is this is the key to encryption. And so now I'm able to sign in. Another place the user experience can get a little rough is, let's say I forgot my password. What can I do? There's a forgot password button. It says here, you can reset your account, but all your data will be lost. Because there's nothing I can do. I can't recover that data for you. I can't email you some sort of magic link to recover it, because that would imply I actually knew what it was. When we respect the user's privacy, we make their life a little bit harder, but it's for their own good. And I think we need to do a little bit better job of communicating that to our users. Why are we doing this? So you see, I reset the account. On the back end here, what that does is just deletes the row in the database that stores all the encrypted data. How do I push play? Where's the play button? Somebody help me here. This? The big button that says slideshow? Thanks. I don't do this often, as I'm sure you've noticed. So implications and trade-offs. You know, the good thing is we've now given the user, they should trust us more if we communicate what we're doing and why we're doing it. Why can't I reset my password? Why, since I lost that password, do I have to recreate my entire address book? It's because we don't have your address book. Regulatory compliance. It's a fact that we do get better regulatory compliance. Interestingly enough, the GDPR does not require you to encrypt your users' data at all, which is rather interesting and also telling of the traditional system. It does encourage encryption, but that's only encryption that you can decrypt yourself using some sort of key. It's encryption for data at rest. But we do bring with that complexity in analytics, complexity with user experience, as we kind of saw here. A problem we're going to be solving next at some point is notifications. We want to be able to tell you when your position's out of range. We want to be able to tell you when the LP you're in is shifting real fast, when tokens are going up and tokens are going down real fast. How do we do that without knowing who you are? I don't have the answer to that one because we don't do it yet, but these are the types of things that we see other protocols do that require getting their email. Give us your email, and then we'll put it in a database right next to your wallet. It'll be safe, trust me. So for designers, for developers out there, keep this in mind when you're building your products. Let's work together. Let's talk about these issues. I know there's some other privacy talks tonight. I know Soulflare's here. These are important things for us to talk about as we build out the ecosystem. We have to make user experiences a little bit more friction in those user experiences, but it's for a good cause. And we can't just abandon the roots of crypto, where we came from, the cypherpunks, the freedom and the privacy that people should expect when they deal with crypto. And that's all I got. Does anybody have any questions? Or did I get anything wrong you want to correct? Yeah, right up front here. Do we have a mic? It's coming. Oh, or in the back.
Hey, how's it going?
Good.
So I'm Mitch from Switchboard. I actually have some experience with like elliptic curve randomness, just because we've done this a lot.
Can you speak up?
Yeah, sorry, can you hear now?
Yeah.
Yeah, so we have a bit of experience with like elliptic curve randomness just from the Oracle side. I was wondering, couldn't you do a password derivation from a signed message if you can guarantee the nonce would be consistent when signing, and then use that as the user's password, so it's consistent per wallet?
I'd have to take that offline and think about it more.
Okay, I'll do it in our chat.
My specialty is not encryption, but yeah, let's talk about that. See me afterward.
Cool.
Yeah. And there's another one up here.
Thanks for the great presentation. Very interesting. How do you think AI can help solve these issues, and what's going to be the challenges that AI can do in order to, I don't know, to increase the risk of penetrations and security loss?
That's a good question. I haven't thought that one through. I don't know. Are you saying how it can make privacy easier to protect?
Yes.
I'm not sure. I don't have an answer there. Sorry.
Okay, thanks.
Sure. All right. Well, thank you all.